Hello guys, welcome back to the Quantity Surveying workshop, and in this video we're going to be treating how to measure the quantities for a retaining wall. The retaining wall is under civil engineering construction, and in civil engineering construction, although some of the operations done when constructing civil engineering structures, they are similar to the operations done when constructing your building works. For example, concrete work in building work, you still see some concrete work in civil engineering work. Form work in building work also applies in civil engineering work. Reinforcement also applies in civil engineering work, similar to building work. The only difference is that the description used in civil engineering work is different from the description used in building work according to our standard method of measurement. So you have to keep that in mind. So in this video, I am going to be relating, every description we make, I'll be relating it to our standard method of measurement. So if you are signed up to my YouTube membership, you are going to be seeing this video earlier than, viewers that are not part of the membership. Also, I am going to be making another video on retaining wall strictly for members only. Now that video on retaining wall is going to have a more complex design, a more complex retaining wall design, and it is going to be more difficult. So if you are capable of grasping the information you need for that difficult design for the retaining wall, you should be able to calculate any kind of retaining wall given to you. So like I said before, my membership is very educative, and you're going to be getting value for your money. So after making the video for the retaining wall, I'm also going to be making a video on how to measure for your helical or spiral staircase for members only. So that is why I said that you are going to be having value for your money. So please subscribe to the membership. You are going to learn a lot in the membership. So as the name implies, retaining wall. What are retaining walls? Retaining walls are structures that are used to retain maybe materials like soil or whatever. It is just a structure that is used to retain materials from seeping into a boundary. So that's the essence of what a retaining wall. And this retaining wall can be made of different materials. It could be made of concrete, reinforced concrete, stones, and so much more. Another thing you need to know is that there is no one particular design for a retaining wall. There are different kinds of retaining walls, and they have different designs. So this is just one design of a retaining wall. There are other different designs. However, if you can grasp what I'm going to be teaching in this video, and with your intuition, you will be able to measure the quantities for other designs of retaining walls that are brought to you to measure. So listen carefully in this video. It is going to help you a lot. Now, to measure the quantities for a retaining wall, I want you to have it in mind that retaining walls are of different parts. This is the base, this is the wall, and in some cases the design may include what? Piers. So as you can see, we have piers spanning throughout the length of the retaining wall. So this is just a caricature design showing the elevation of the retaining wall. So if you section that retaining wall, you are going to be having this drawing. Now this is the section of the retaining wall, and this is the plan of the retaining wall. Now let us look at the section and what do we have. So if I bring this side by side, you can see they are similar. When you cut this retaining wall like this, right? Or let's just use this edge. Let's just say that this is the cut. This after you've cut the retaining wall. You can see what we have here is similar to what we have in this section. So they told us that the thickness on top is 0.30 meters, which is 300 millimeters. From here to here is 1.2 meters, and if you look at the base, they told us that from here to here is 2.4 meters. Now let us look at the projection of the piers. Now you can see this dotted line here. What does that mean? It means that there's something there, which is what? The piers. I hope that makes sense. So when you are looking at this drawing from this view, right, you know you are going to be seeing this side. Now that is what you are seeing here. Those are the what? Piers, right? And they say that the projection of the pier is what? 300 millimeters. That's 0.30 meters. And as you can see, the retaining wall is what? Holding soil. So this retaining wall now was used to kind of give an elevation to this side of what? The terrain, thereby making this side lower. So that is the purpose of what? A retaining wall. As you can see, the terrain here is higher than this side because of what? The retaining wall. So now if you look at this, you can see we also have other elements of the retaining wall. You can see we have continuous pockets of what? Ashes between what? The piers. So now if you look at this drawing, as you can see what I've done here with red biro, red pen, this point here, they are going to what? Pour ashes. So in between each of the piers, ashes will be poured. In between each of the piers, there will be ashes. In between, there will be ashes, and so on and so forth till we get to the what? Entire length of the what? Retaining wall. Now they also said that what? There's going to be what we call what? Weep holes. Now this is for what? Draining water from on top. So water seeping into the soil will be drained down. That is what the purpose of what? The weep holes. So we're going to be calculating for what? The weep holes. And they said that it is what? 1.8 meters center to what? Center. The piers are at what? 5 meters what? Center to what? Center. So it means that for every 5 meters, we are going to be finding what? A pier. And for every 1.8 meters, you are going to be finding what? Weep holes. I hope that makes sense. Now, if you look at this now, they say that what we have here is mass concrete, is a mass concrete wall, not a reinforced concrete wall. So the mixed ratio is 1:2:4, and is what? 20 mm aggregates. Similar to the base of the retaining wall, the concrete base is what? 1:2:4, 20 mm aggregates. Now let's look at this. They say that from here, let's just see this is our ground level when we come to the site. So now it means that for us to get to this level where the base is going to be sitting, we have to dig as deep as what? 1.50 meters into the ground. So you can see from here to here is 1.50 meters. So to get to this level here, we have to dig what? 1.50 meters. So as you can see in this drawing here, this is our ground level. So you have to dig down by what? 1.50 meters, so that we can get to this surface level where the base is going to be what? Laid. I hope that makes sense. So now, what is the height of our wall? They say that the height of our wall from the top of the base down to the top of the retaining wall is what? 4 meters. So you see that the retaining wall is quite tall. What is the standard height of one floor of a building? Is from 3 meters to, let's say, 3.5 meters if you want more headroom. Now you can see that the retaining wall is what? 4 meters. That is to show you how high the wall of the retaining wall is. That is why it is what? A civil engineering what? Structure, because civil engineering structures are what? Massive. So you can see how high the retaining wall is. 4 meters, as longer than the height of one floor of what? A building. So now the thickness of the retaining wall, as you can see, is what? 900 millimeters, which is 0.90 meters. Now let's go to the plan. Now this is the section when you cut the retaining wall, right? Now what do we see in the plan? Now you can see that if you look at this plan, this is simple orthographic projection that you did when you're doing your technical drawing and your basic technology. So let me just revise it again. So your plan is the view of what you are seeing of this retaining wall from on top. So now let us just remove all the soil and here, right? What are we going to be seeing from above, we're going to be seeing the thickness of this what wall on top. So it means that this is going to be our what wall thickness here, because as you can see, they told us that the wall is connected to piers, and as you can see, these are the piers here going throughout the span of the retaining wall, whatever the case may be. So now, since this is the what top of the wall, you can see that piers are connected to it. Now if you don't know what these piers are like, let's say, okay, if you look at your fence, right, there are times in your fence when they lay the first course, you are going to see something like a big pillar before they continue the next course, and then the big pillar continues again before you see the next course of block in your fence. So those big pillars that are made with your block, right, to serve as a column, let me just put it that way, as a column for the fence, are called piers. So that is something similar we have in this design. So these are what piers. Now if you look at this from on top, this wall is not straight, it's not a regular rectangle, it is what a trapezium, meaning that this place is slanting. However, because of it is slanting from this view, when you look at it from on top, it is going to be looking what flat. So this is the projection from here to here, that is why you are seeing it what flat, right? So now if you can see, for the base, this projection from here to here is the projection from here to here. The projection from here to here is the projection from here to here. As you can see, this side is accommodating what a base for the what piers. Similarly, from the plan, you can see it is supporting the what piers. This is the base. I hope that makes sense. So now let's look at the dimension. So you can see now that from this point to this point, they say it was 1.20. This is it from here to here, 1.20 meters. The same thing you have in your what section. Now let's just look at our piers. Now they say that the projection here from here to here was 0.30. You can see that this is the projection, 0.30, and the thickness is what 0.75, that's 750 millimeters. Now they say that the length, how wide the base would be, is what 2.40 meters, and you can see it is as wide as what 2.40 meters. So that is just how you read your what drawing for your retaining wall. It's as easy as that. So you can see there's a breaking line here because it shows that the retaining wall is continuous. It is going to be so long, a long distance that is going to what span. So now with this, we've what interpreted the drawing for our what retaining wall. The next thing now we're going to look at are the what taking off lists that we need to measure before we can now say that yes, we've completely measured all the what quantities for the what retaining wall. So as you can see, the taking off list for our retaining wall is divided into 4 sections. Number 1, the earthworks. That's everything we're going to be doing concerning, you know, excavation and all those good stuff. The second one is what concrete work. The third one is what concrete ancillaries. What do you mean by concrete ancillaries? That's the things that need to be put in place before you what cast your concrete, and then reinforcement if need be. So in this series, we're going to be looking at 3: the earthworks, concrete works, and the concrete ancillaries. As for the reinforcement, it is still the same process that we've been treating how to measure reinforcements before. So if you want to get an idea on how to measure reinforcement, you can watch our previous videos on where we treated how to measure reinforcement. It is easy. Understand your drawing, measure the reinforcement in linear meters, get the total reinforcement used for the retaining wall, and then convert it to what tons. And the reinforcement should be grouped according to their what sizes. So with this, now we can now what begin with our what earthworks. So for our earthworks, what are the things we need to what scatter? Number 1, the topsoil removal. So for every site, once you get to the site, the first thing you should do before you begin construction is the what removal of topsoil. So I told you that there are similarities between building work and civil engineering works. So you can see that this is a similarity. Building works has removal of topsoil. Civil engineering works has what removal of topsoil. The next one is what trench excavation. Now remember that the base of the retaining wall is going to be what sunk inside the ground. So if you look at the drawing like I did before concerning the excavation, you can see that what they had to excavate what a trench for the what retaining wall where the base is going to what settle. So you can see we also have trench excavation here, similar to what building work. And then after all your excavations, you are now going to what dispose the excavation. So disposal of excavation. So there are similarities between civil engineering works and what building works. So the next one now is what the concrete works. Now you can see that concrete work is in civil engineering work and in the what building works. But the way we measure concrete work in building work is straightforward than the way we measure concrete work in civil engineering work. Why? Because in civil engineering work, we are dealing with massive structures here. And in a situation where these massive structures are made of concrete, you don't expect that work to be done in one day. So because of these structures are massive, it is going to affect procurement of materials, and it is going to affect the placement of these what materials. That is why now you can see that concrete work is divided into two sections: provision of the concrete and what placing of the concrete. If it were in building works, you know that we'll just measure the concrete once as in situ concrete. But now in civil engineering work, now you can see we have to measure for what provision of concrete. Now this provision of concrete is to get the total volume of the concrete for all the structures that we are going to use them for what procurement, right? To tell them that okay, we need so amount of what concrete. Now remember that it depends on the kind of what method they are using for this construction, whether it's mechanized construction or manual labor. But nowadays it is mechanized construction, right? So now you are not going to determine the volume of concrete that you are going to what bring to the site using what a self-loading concrete mixer. So now you see that I always say, to understand measurement, you have to understand the process of what the construction. Once you understand the process of the construction, everything is easy. It's just for you to read your drawing and then measure. It's as easy as that. So now, because we're talking about mass structures here, you now have to what use self-loading concrete mixers to bring concrete to the site. Now these self-loading concrete mixers won't just bring one portion of the cement right to the site. It has to go and come back multiple times before the whole structure that is made of concrete is complete. I don't know, I hope that makes sense. So now that is why we have to what measure for the what volume of concrete to cater for the provision of the concrete, which is for concrete that they are going to what bring to site. Now the next is what placing of concrete. Now like I said before, construction is a very intricate process. Because of these structures and mass structures, like I said before, you don't expect them to complete it in one day, right? So now the concrete that you're going to be bringing to the site, they're going to be bringing it in such a way that the retaining wall, the concrete for the retaining wall will be completed in stages. Because one day, imagine the length of the retaining wall was 100 meters. So you know the volume of concrete you're going to be needing to complete that 100 meters of retaining wall, right? So now the concrete you're going to be bringing to the site would be in such a way that the concrete for the retaining wall will be casted in stages, that stage by stage, until we complete the whole retaining wall. I hope that makes sense. That is why what we have provision of concrete separate, placing of concrete separate. Now in our standard method of measurement, when we get there, you're going to be seeing what stages have been put in place for what placing of concrete. So concrete ancillaries like our formwork, whip holes, and the ashes. These ones are simple. So reinforcements, like I said before, easy to measure. So before we start, I forgot to add one of the work on earthworks, and that's surface preparation. So this surface preparation is similar to what you know as leveling and compaction in building construction. So you know that after you dig your trench, you can't just pour concrete immediately because of settlement, right? So you have to compact the surface of this trench smooth to make sure that the surface is properly compacted to receive the concrete, and that is the essence of the surface preparation. So as I've explained everything that needs to be explained in the taking of list, we can now begin our measurement immediately.